Okay, can you confirm if you are able to see my screen? Guys, someone please confirm in chat. Okay, fair enough. So, okay, let me add another notes file. Okay, so in last lecture, we covered till this CSV parsing part. We will expand it a little bit further, and in parallel, we will cover a little bit of JSON format as well, because that is yet another ridiculously common format, which you will see if you are mostly dealing with either some sort of feeds or some sort party source of data, or probably some sort of API. For those cases, JSON kind of this happens to be really popular choice. So we will take a look at that as well. Give me a minute. Okay. So let us start with JSON. Reading JSON file, and the reason is it is yet another very common format for passing data around, which can be from one service to another in API request or response, or some sort of external data source. For example, you may be looking at either malware feeds or some sort of threat intelligence feeds, and they may have option to provide data either as CSV or JSON, or maybe only as JSON. So just for sake of completeness, since we covered CSV, we will briefly cover JSON as well. So just like previous case, we will use an external library. It is a really famous one actually. It is called Enlowman JSON. I will put a link here. Wait, what? Yeah. So it is here. I will put a link in chat as well. Okay. So there are again various libraries. Some will be extremely fast. Some will be extremely memory efficient. Some will be very easy to use. Okay. So I am picking this library because this is probably easiest library to deal with for JSON. It is not the most performant one. There are libraries which give slightly better performance than this. It is not most memory efficient one either. There are libraries which focus more on memory efficiency than ease of use. So which means that basically means that as long as our JSON is not very huge, we should be able to process it using this particular library. But if JSON becomes very huge, there are other libraries which you should be using, which focus more on memory efficiency, so that you don't basically run out of memory while trying to read and deal with that JSON. Okay. Now, just like that CSV case, it is single header file. That means that download, include, done. So let us download that JSON header, and okay, where is that? Include, single include JSON .spp. Okay, so that single include is here. Okay, what is the definition of very huge? Again, that more likely depends upon this configuration of your system. Mostly it depends upon how much memory you can throw at it. So if you have crap ton of RAM, you can probably load gigs of JSON data just fine and not really worry about it. But if you have a system which only has say 4 GB of RAM, then you will have to think about how to deal with JSON, which is approaching its file size somewhere around the GB. So that mostly depends upon how much memory you can throw at it. But generally, most of the JSON data that you are going to deal with, it will be somewhere in megabytes. And if you are approaching gigabytes, I will anyway recommend that you should be looking at some other JSON libraries which focus more on efficiency side instead of ease of use side. Because if you throw that huge JSON file at this particular library, it will obviously take some time, and depending upon your particular use case, it may be worthwhile investment to put effort to basically port your code base to some other more performant library. So again, that depends upon your specific use case, specific resources that you have, or are you are able to throw at the problem. Okay, so yeah, I have shared that link. So it is time to basically download that. Okay, so this header file is downloaded, and I also have a JSON file with me that we will use for some practice, and link for that again I have put in the chat. I will put here as well. Okay, sample JSON file. So this is the JSON file that we are going to use, and I have already downloaded it here, which looks something like this. It is from MS Feed. We don't really care too much about the specific data. We are only going to worry about how to extract some particular data out of this JSON. So just like previous case, we start by including the header file, include json.hpp. Okay, and how much is the size here? Okay, it is a pretty small one. And include fstream because I need to read it from file. Okay, and then okay, so now you need to open this file, fstream file, and the name is defaults.json. Okay, so we have opened it here, and then we want to read and parse it. So send data equal to JSON, and we want to parse this. Okay, so what will happen here? We just open a file, and then we basically pass the corresponding object to this library directly, and it will deal with reading the file, parsing the JSON, and basically preparing it in a way so that we can actually use it. Okay, so let us build this much and confirm that this one actually works. Okay, so time to go to this. Oh wait, it is that it seems. Five. Oh wait, it says that it is unable to read this. That means we screwed up somewhere in the file. Oh wait. Obviously that JSON file is not present here. So obviously it can't really parse that. So what I will do, I will download it here in this remote machine as well. And now I can run this. Yes, it is able to read and parse it because we are not really seeing any exception being thrown here. So this one so far works. Okay. Now we want to take a look at that JSON file to see what sort of data we can expect. And depending upon that, we will write some code here. So here, what I see that this is some sort of array. So I need to check for array and then I need to iterate over it. So what I can do here, we can check if data is array. So if data is array, okay, this should pass here. And then I want to iterate over each element here. So for auto object out of data, we will probably do something here. And in that thing, what we want to do, we want to see, okay, so there is feed, there is add, okay. So we want to extract feed and tag. And before we do that, we also need a sanity check. We need to basically ensure that this key is actually present. If object dot contains feed auto feed equal to object feed, so we should have feed here, and probably we can extract name and provider. So we do the same check again. If feed dot contains name and feed dot contains provider. So if both of these are correct, what we want to do, we want to extract them as a string. Okay, so for a string, I need another header, include a string name equal to feed name get std string, and similarly I can also get provider get as std string. Okay, and now we can possibly print it. Name as name and provider as provider, and then add a new line. Okay, time to. Okay, so time to build this again. 5, and if I run it, here it is able to extract that data out of that JSON and print everything here in whatever format we want to deal with. So if we want some specific key and its value, we can do that. If we want to iterate over an array, that is basically JSON array, we can do that. We want to check if some key is present or not present, we can do all of this stuff. And then obviously we can basically extract that value by specifying that key as index here, and then we specify that in which format we want it, and we get that in this particular format. So this is how this JSON parsing is going to work. All the heavy lifting is being done by this pretty simple library that is only one header file, and then we have to just rinse and repeat it as per our use case. So not every time your root will be an array. Possibly many times you will have your document as a huge object, and some of the keys will have some sort of arrays. So you just modify it accordingly. So if you expect some huge JSON object, so you can check instead of is array, you can check for is object. So for example, uh, instead of that, you can also do is object. That will tell you whether it is a JSON object or not. So if it is an array, it will be false. Similarly, you can check for if the value is Boolean, or if it is number, or if it is a string, and that sort of stuff. Okay, and based on that you can do rest of the extraction and remaining sanity checks. So this is how we do it. And obviously, if you do not want to do it like this, you want to do the file read on your own. Possibly you want to read the entire contents in one shot and then use this library. That is also doable. There will be cases where your file will not have one single JSON. Instead, what it will have one JSON per line. Okay, so in those cases, if you use this approach here, that you open the file and pass the file stream directly to this library, that will not work because the file itself does not contain one valid JSON. Okay, so in that case, you will have to read the file line by line, and then you will have to parse each line as a separate JSON. But that will not be very difficult. You can already combine the things that we covered in previous lecture with this one, and you can easily solve that part. Okay, so any questions so far? Anyone got any questions related to file, related to CSV, related to JSON? Once more, as in once more what? That JSON parsing one? Okay, I suppose you are talking about the JSON parsing. So my point was that there will be some cases. Okay, so let me two possibilities. One is the file contains one valid JSON which can contain other and one valid JSON object in turn can contain other valid objects, arrays, key value pairs. So that is one option. Second option is that the file contains one valid JSON object per line. Okay, so for case one, we can open file and pass the fstream object to this library. Okay, and it will work. Now for case 2, we can open file, read it line by line, and pass one line at a time to this Lowman JSON parse, and it will work. Okay. So there are these two cases basically that you are going to encounter in your real life, and depending upon the case, you will have to fine tune the approach. So if it is this particular case, you can do this. You don't have to read the file on your own. For second case, you have to do this. And for opening the file, reading line by line, I think we covered somewhere around here. So you can take a look at this one, read from file, and here we are basically reading it line by line. So you do something like this, and then instead of parsing this object here, you can basically pass this line here, and it will happily parse that line for you, and then you can use some stuff like this to extract data out of it. So basically, you have to combine this thing with this thing, depending upon which particular case you are dealing with. Yes, Ravindra, I am waiting for your question. So to access local GitHub Copilot Copilot chats which are stored in workspace VSCDB file, when you want to extract the exact chat session, we are stored in array as interactive session. Okay. Is that a JSON file? Okay, so you are saying that that VSCDB file contains chat session which you can convert to JSON. Okay, and Ravind, I'm not really sure. Okay, yeah, you are typing. Now, will the parsing work at one go for all workspaces? That depends upon how it turns out after conversion. If after converting your file contains one JSON object, which in turn contains other chat sessions or other messages and responses, then you can use approach one. If it contains one JSON per line, you can use approach two. Or if it contains something nonsensical that I have seen happening in some places, that it is basically a chain of JSON objects, but not really a valid JSON array. And each JSON object spans across multiple lines. So no, you won't be able to parse that thing properly with any JSON library, because the resulting file will not really be a valid JSON file. So you will have to somehow fix that and turn that into either a JSON array or some other object, which in turn contains those other individual valid JSON objects, and only then you will be able to parse that. Okay, so I think you can share it on Discord. I will take a look and then I will be able to tell how you can pass that. Okay. Okay. So let us move on to next topic. Okay. Before moving on to next topic, let me put a very simple question. Whether we take case of this today's lecture where we are parsing JSON and extracting some key value pair, or we take case of the CSV parsing that we did in previous session where we were extracting some data about some particular malware sample feed. Now, obviously, when we are parsing it, probably we also want to pass that data around to some other function or to some other component of our bigger ecosystem, which may be within exact same compiled binary. That is fine. But the idea is that instead of doing everything in one single place, we want to split it apart to keep things easy. And since we are splitting it apart, say across functions, we want to be able to pass that data around. Suppose I extract some set of data and I want some stuff to happen on that particular data. Maybe it is some sort of check on that data or some sort of other processing, and I want to pass it to a bunch of functions. How do I do that? So the question is this: how do I pass multiple data points related to something which is can be malware sample or threat intel etc to bunch of functions? So there are a couple of possibilities. One option is that we can pass it via bunch of different variables as function arguments. Okay, so suppose here we are taking bunch of strings. So if whole thing contains say 5 different strings per entry, we can have 5 parameters for each function that wants to process that data, and we can pass those 5 strings as parameter, and then we can possibly get some output out of that particular function. So with this possibility, what exactly is wrong? Or rather, is there something which can turn into potentially problematic situation down the line? Anyone willing to take a guess? If we take multiple data points into multiple variables and we pass those multiple variables as function arguments, is it fine or is it not fine? Anyone? Same problem as array. I'm not sure if I understand you. Can you please elaborate a little bit? So are you saying that instead of passing multiple individual values, we can pass some sort of array or vector? Okay, that will work only when all your data points are of exactly same type, but that is not given. There will be cases where one data point may be string, second data point maybe some numeric, third one maybe a Boolean, and all those data points belong to exact same entry. And you want to pass that along. So you can't really make a vector or array out of multiple different data types. You can convert it to a string and then pass it, and then in each function you have to convert from a string back to some other thing, and you will be wasting a lot of time at runtime by doing this pointerless conversion. We don't want to do that. Using map, maybe key value pair. Okay. Anything else? All depends upon how data is structured. Okay. Okay. Here's the simple solution. You just have to notice something. Okay. So what? Okay. Problem. Multiple arguments. Arguments cannot change order of arguments. Cannot add new data points for same entry without a lot of change. Basically, all the functions you have to update them again, and if you forget something, bad things can happen. Okay, so observation. One is multiple data points which jointly make one entry. Okay, it can be basically anything. We don't really care about internals of entry. It may be malware, sample data, threat intel, some other data, some API response. We don't really care about that. And most of the time we want to treat the entire set of data points as one unit of data for sake of processing. Okay, as in we don't want to process individual data point. We want to process the entire set at once. Okay. Now, if you notice something about the code here, or probably some stuff here, right? What you will see that in many cases, we have, for example, you can take a look here. And if you recall from initial discussions about variable data types, and if you put the same pattern here, you will notice that this is the variable name, that is fine. This is the value, that is also fine. But somehow this is a data type, and this is not a fundamental data type, right? This thing doesn't really fit into any fundamental data types that we covered. It is something entirely different. And somehow this particular thing here is able to combine a lot of things about some particular entry. In this particular case, it is a file path or some file system. And it is able to combine that sort of stuff in one thing that kind of looks like a data type, behaves like a data type, feels like a data type, but it is still is able to somehow combine and wrap things up so that from our view, instead of a bunch of different data points describing one entity, it is one variable, or rather one data type, describing that particular entity basically completely. And we want to do something like this here as well. So the third observation is, in past we have seen things which look like data type, behave like data type, but are not any of the fundamental data types. Yet those things somehow combine everything and describe one entity almost completely, instead of relying on multiple individual data points. Okay, so are these three observation points clear to everyone, or is anyone getting confused somewhere? Are these three observation points clear to everyone? Okay. So what we will do, we will do something like this. Okay. The rest of the C++ is already using it, so we might as well use it, because this really looks like a rather good idea, because we have multiple data points and those data points are collectively describing one thing. So instead of having this fractured thing, we want to have one data type. Okay, so wait, it's not. Then we have a solution, and this is basically compound data types. And we take bunch of data types, fundamentals, custom, compound ones, etc. We club them together. We name that clubbed bunch, and voila, we have a new compound data type. Okay, so this works in C++. There is something called a structure and there is something called class. We will cover both of them one by one. We define it using that struct keyword and we define it using class keyword. So we will start from structure. Okay, and instead of doing something like this, I want to create a structure and I want to track each entity using a structure. So syntax is very simple, the struct keyword, and then I give it some name. So the JSON file, oh damn, the SSH is broken again. TTMP, okay, CMake will debug, default.json. Okay, so let us name it threat intel feed because that is where I got the data. And we do something like this. So syntax is like this. We say struct, then we give it a name, then here we provide data type, variable name, and we repeat it as required. So here what we are tracking? Right now we are tracking a name and provider. So what we will do, we will have two separate variables inside this, name and provider. Okay. And this can have multiple different types of data types clubbed together. That is absolutely fine. There is no such restriction that you can't mix and match these. You can definitely do that. Okay, so we have our structure defined here. Then what we will do, we will declare a variable by using this name as data type. Okay, so feed is here, feed entry. Okay, and instead of using two separate variables here, we can use this as well. There is nothing wrong, or we can simply, okay, let us keep it same. And then we want to basically show this data inside this thing. So how do I access the individual variable here? Using the dot operator. So I put this variable name dot, and then I pick one of the variables where I want to do something, and I assign it like this. Similarly, provider equal to provider. Okay. Declare variable same as that. Struct name, variable name, and access components. It is struct variable name dot member variable name. Okay, so these inner variables are called basically members. These inner variables are called member variables. Okay, so we have it here. Okay, and now we can define a function which does something to this feed entry. So let us, we can have something like this, threat intel feed, and we can basically put it there, and it becomes feed.name and feed.provider. Okay, so instead of doing it in one place, we are passing it in another place, and we can call this function from here, print entry, feed entry. Okay, and we can build this. Just done. 5, and output is just like previous case. Okay, now let us suppose I want to add one more data point about this. So let us take a look at this thing, fall.json. So we have feed, we have enabled, we have bunch of things. So let me pick, say, enabled. Okay, and it is boolean, so bool enabled. Okay, I only put it here. Now if I if I wanted the previous approach where I am passing along multiple data points, instead of this one change, I would also have to do change in a lot of other places. But if I am doing this and I add it here and I compile it just fine, it will work. Okay. Or I can wait. Let us extract that thing here. Feed dot contains enabled and bool enabled equal to feed enabled dot get bool, and I pass it along here. Feed entry enabled equal to enabled. Okay, and I build it again. If it is still working. Now, if you note here, when I am parsing the JSON, I updated it, but I did not update it. I did not update it here. Okay, because I don't have to pass this separately. I am passing this object and all the member functions are getting passed along just fine. I don't have to change function signature. Okay. And then I can only update individual functions where I am basically going to use that particular member function, and I can leave others just fine and it will keep working. I don't have to track everything manually ever again. So let us print this as well. Enabled feed dot enabled. Time to build it again. And here we are getting that enabled field as well based on 0 or 1. Okay. So this is how we can do it. Okay. Now, looking at this code, is there something that is kind of problematic or less than ideal? Anyone? No comments here? Okay. So the potentially problematic thing with this one is that this function is only useful to process this, right? But we are basically keeping them separate. The function is completely separate and this structure is completely separate. And that means we have two things which are related to same thing, but we are tracking them separately, right? And at some other point of time in future, if someone sees the function entry called print entry, it is not immediately obvious unless you also look at this one, that okay, this is only useful for printing uh, data from this particular thing and not anything else. So what we can do, instead of keeping it outside, we can move this thing inside this structure, because again this is related to exactly same thing, so why even bother tracking it separately? Which means we can have inner functions are called member functions, okay, and function declarations. Okay, so what we can do, we can cut it from here, we can paste it here, okay, and we can probably rename it to print, because well it is printing, this is specific to this particular struct now, and we don't even have to specify this, because well we are not going to pass it separately, it can access the inner data members just fine, and we can remove this here, okay, and we can remove this and we can call it feed entry dot print, variable name access components, and it is member function name. So we can compile this. And it works just fine. And now we have basically moved this inside this particular structure. So not only we can club the individual data points, we can also club related functions with them. So instead of tracking data points separately and functions which can process them separately, we put everything together, we track everything together. Okay. Now it is not like that you can't pass some parameter here. You can definitely pass a parameter. If you want, we can pass something like this, and we can even print that. So it is fine. You can pass parameters as well. Just that if we are going to access only this, we don't have to pass this separately. We can access it directly because we are, well, sitting within a okay, yes, I forgot this. So it is foo. And oh, wait, I'm, hmm. And here we are able to pass some argument, and obviously we can access that argument as well from within this function, just like we are able to access all these data members. Okay, any questions so far? Our previous lectures recording available somewhere? Yes, it is available on Discord. No questions? Okay, so we will move on. Now, for class, the only thing that changes, there are only two things that change. Uh, Syntax for class, replace struct with class, and everything is private by default. And by private, what I mean that I can't really access that from outside. That basically becomes hidden from outer world. So if I do something like this here and I compile it, it will not compile. Okay. And the compiler is saying that it is private within this context, so we can't really access it directly. So I can modify the access saying that it is public, and then it will work. And it is working just like the structure. So now someone can ask that, okay, if it is the only difference between structure and class and both are other than these differences, one is being the different keyword and second one being that class will keep everything private unless we specifically ask to make it public. Why even bother having to separate things, right? We can only have one or another. What is the point? The point is that C++ kind of borrowed a lot of stuff from C, and that struct thing is coming from C. The difference being that struct in C is basically only clubbing of data types and variables, and obviously everything is public because C syntax is pretty much simple and it does not have a lot of higher level abstractions and concepts. So it gets borrowed from there to C++, and then eventually it was like that, okay, we are having a class, let us also make a struct something like a class, but the only change that it will have everything public by default, just like its C counterpart, but with little bit of extra extensions. So that is how we ended up with basically two things which could have been one single thing. Okay. Now, before we proceed further, there is something that we should be talking about, and this is a topic which generally gets skipped in a lot of books. And the topic is basically something we can call composability. Okay, so what does it mean? That when we are designing a system, okay, ideally, we want to split the system in bunch of individual some sort of chunks or blocks, okay? And we want to split them in such a way that we can combine various blocks together to make bigger blocks, and then we can combine bigger blocks to make even bigger or even more complex blocks, so on and so forth. And if we do that, instead of someone or rather one single person have to know everything about the system that we are going to design or are designing or have designed, instead of knowing everything from top to bottom, every single person can have slightly different set of knowledge about the system. For example, someone can be really good with the bigger blocks, but may not be that good with whatever is happening within those bigger blocks. So if we can provide those bigger blocks to that guy, he will combine them in some creative ways, and he will be able to solve some very complex problems which will not be easily tractable by someone who does not have that much expertise on those bigger blocks. Similarly, there can be some other person whose expertise lies in those mid-level blocks. He does not have that much grip upon how to solve very complex problems at even higher level, but he can take bunch of easier blocks and he can combine them creatively in such a way that those medium blocks can be further combined by that next guy to solve pretty complicated problems, and so on and so forth. So at every layer we can have different set of people who are expert in different levels of depths of the system, and eventually we end up with a team where we have someone who knows the thing at absolute deep level, from there all the way till the person who can take those blocks and can solve ridiculously complicated problems in pretty less effort comparatively. Okay, and obviously that this particular thing makes maintaining and expanding our system to tackle more and more cases much easier. So now, when we want to split a system in some sort of blocks, there are multiple ways of doing things. Okay, so one particular way is that you think about your system as a set of instructions. Okay, so you focus more on how to do something, and then you take those set of instructions and you give that a name, and for other higher levels you treat that name as some sort of individual instruction. Okay, so at that layer you don't really care about what is happening within that named set of instructions. You just squint your eyes and pretend that that particular bunch of instructions is itself some sort of complex instructions which will do something for you, and then you take those complex instructions, make a set out of it, give that a name, ad infinitum as required, and eventually you end up with a very complex system which can be broken down into a bunch of different named group of instructions all the way till individual lines of source of basically individual lines of code in your program, which are basically abstracted in functions, and then those are abstracted in other bunch of functions which are simply calling some other functions and passing data around, doing some extra stuff, that sort of stuff. So that is one way of doing things, and you can think of this approach is something like imperative. Okay, you are mostly focusing on how to do something, as in you are thinking in terms of steps of solving a problem, and not really thinking in terms of data. Okay, so you are taking data as you go, modifying it, twisting it, copying it, splitting it apart. That is basically secondary thought. Your biggest focus is on how to do something. So that is one way of doing things. And that is how many languages operate, for example, C. Then there is another line of thought where you say that, hey, why are we mixing how to do thing and the thing itself on which something has to be done, as in you want to keep data and instruction completely separate. You don't want to make a khichdi of them, like in the case of imperative, right? You want to keep them completely separate, or as far as possible you want to keep them completely separate. So in that case, what you do, you start thinking, you basically borrow the line of thought from maths. And if you remember something about maths from your school days, is that in maths you have concept of some sort of functions. Okay, in maths you have some functions which operate on some sort of data. Maybe it is mapping a number to some other set of numbers, or it is operating on sets or something like that. And you think that, okay, this sounds interesting. Instead of doing a khichdi, what we can do, we can have some sort of mathematical looking function. We call them actually pure functions. Pure function basically means that it will not have some extra side effect that can create issues. Okay, so for example, if you define a function which takes two arguments, both numbers, and returns another number after adding them, that will be basically a pure function. You can call the same function 1,000 times and nothing new extra side effect will happen. So you borrow the line of thought and you structure your program in such a way that it is largely operating on pure functions, and you only plug data only when needed, and you ensure that the functions are basically first party blocks. So instead of passing around data, you are basically passing around function. And that line of thought when it comes to programming, that is called functional programming. So if you remember from topic of functions, we talked about something called std function, those lambdas, that std bind, where we were able to bind some parameter to some specific value or some other variable, and then we could squint our eyes and pretend that, hey, this is some new function. Okay, so that is coming from that functional programming approach. And if you want to see extremes of this particular approach, you can take a look at languages like Haskell or Lisp, which work like this. Instead of thinking about making a khichdi of instruction and data, you design in terms of pure functions, and then you pass around functions, and eventually you pass the data at very late stage. So that is yet another way of composing the program. You start with pure functions, then you combine those pure functions, or you mutate those pure functions, you end up with some other pure functions ad infinitum, and you plug the data at very end for something to happen. Then there is yet another chain of thought, and that goes in yet another separate direction. And it says that, hey, end of the day, in our real life, we care more about the data, right? If you look around in your jobs, you are actually caring more about data, right? You have a database, you have a feed has some data, you care about those malware samples, you care about those threat intelligence feeds, you care about correlation on top of data, you care about detection, which is again processing the data to give out some other data, right? You don't care too much about how that correlation is happening. You are caring about the data. I have a feed which has these malicious domains. Am I hitting any of those domains? This feed has list of malicious IP addresses. Are we hitting those IP addresses, or are we seeing any traffic from those IP addresses, right? So when you are doing that sort of stuff, you are not thinking too much in terms of how this thing is working under the hood. Okay, you are thinking in terms of data. You have some data, and out of that you want some other data out of it. Okay, so data input, data output, you are focusing on data. Data is what is driving your life right now. So if our real life is centered around data, we are on day-to-day basis, we are basically dealing with data in, data out. So why are we focusing too much upon how to do those things? Sure, we have to think about how to do those things, but since the data is the prime thing on which our life is being centered upon, we might as well treat data as the first party thing that we want to deal with, and then we slap the rest of how to do part on that data. So when we expand that particular line of thought to programming languages, that basically turns into something called object-oriented programming. Okay, so instead of thinking in terms of individual instructions or lines of code, or thinking in terms of pure functions or functions as first party objects that you can pass around, you start thinking in terms of objects itself. Okay, so objects are what are the things which are going to basically dictate your line of thought, and then you do some stuff on those objects. You get some other objects, you pass that object, do some other stuff, you create object, you do something like that. So that basically becomes your object-oriented programming. And in all these three lines of thought, the basic problem that we are trying to solve is how to ensure that our system is composable. We should have some very basic blocks. We should have ability to make blocks on demand on top of other blocks, and then you combine them, and block by block, block by block, you slowly and steadily increase the complexity, and eventually you are able to deal with some really complicated things, even though you started with very simple things. Okay, so that is the composability thing. Okay, any questions in this topic of composability? Okay, I will take that as no questions. Okay, so I think someone is typing. Okay, all clear with composability. Fine. So in C++, we will talk about that object-oriented programming now, because that is going to make our life easier. And when we say about composability, one more thing, when you are designing a system, okay, do not fall in the trap of sticking one way of solving composability. Okay, there are multiple lines of thought, there are multiple ways of doing things, but please don't become a purist. Don't become someone there who goes that, okay, either object-oriented programming or absolutely nothing, or only pure functions, functional programming, or absolutely nothing, or only imperative programming, or absolutely nothing. Don't be like that. Okay, many times solving some problem via object-oriented programming will make more sense than via functional programming. In that case, use object-oriented programming. There will also be cases where going in that functional programming paradigm will make more sense. So in that case, go with that functional programming. There will be cases where that imperative part will make more sense. Go with imperative. There will be cases where different blocks will have different combinations of more than one way of composing problems. Do mix them. Okay, there is no shame in mixing object-oriented programming with functional programming or imperative, or doing some other stuff. Or maybe you are doing it something at one way, at one place, doing some different stuff, some other way in some different block of your program. That is absolutely fine. The focus should be on solving the problem efficiently and solving it cleanly. Okay, there is no point of being a purist just for sake of being a purist. Okay, so now for object-oriented programming. And obviously, the center stage is taken by objects which wrap data. Okay, because we want to think in terms of data. Now, there are some other concepts which come with it, which we will keep expanding and keep repeating for at least in next lecture as well. So there are some key concepts. One is called class, and that will be basically your class keyword or struct keyword. So this is basically a template defining which data points and functions will be clubbed together. Okay, so for example, here we are clubbing these three data points and one related function. All of these are clubbed together. So this is basically a template. This is a class. Then we have object, a variable of data type of some class. So This is a class, and this is an object. Okay, so this is basically the variable of the data type of that class, and we, instead of calling it a simple variable, we call it an object just for sake of distinction. By calling it object, we are basically saying that this has components. Okay, this is something that can be broken down. This has some extra components. It is a compound type. So then there are things like encapsulation, there is abstraction, there is polymorphism, there is inheritance. Okay, can anyone tell me what is encapsulation? Okay, so encapsulation is basically the act of bundling related data and function together. Okay, so here we will say that this class that feed encapsulates these three data members and this one function member. All these are related to one single entity. So we say that this class encapsulates this much stuff. Then we have abstraction. What is abstraction? Abstraction means the act, it is basically the act of hiding non-essential information. What does this mean? What is non-essential? This is the definition that you keep seeing on various blogs, forums, books. But this hinges upon this non-essential. So what is non-essential? Anyone? Okay. So basically this means we want to disclose absolute minimum to the outer world. Question, why? What is so bad if we expose more than absolute minimum? What will go wrong? If we are saying that in name of abstraction, we want to hide everything non-essential or hide everything that is not basically absolute minimum to be disclosed, why? What good is going to come out of it? Or rather, if we do not do this, what is the bad thing that will happen or can happen? Anyone? Oh shit, can see screen. I hate this Teams thing already. Wait. Okay. Can you see the screen now? Okay. Fine. So back to the question. When we say that abstraction is hiding non-essential information and we do not want to disclose anything that is not absolute minimum, the question is, okay, anyone with access to the object can change data. Okay, so what is wrong with that? We are passing the object around because we want to process data, and by processing at certain stages, we will want to modify that data. So what is wrong? Or if you say that some user of the program will be able to modify it, then someone else can ask, why not put it behind some sort of authentication and authorization? I mean, identity access management is something you already see in your daily life, in your office. You log into the some system, you get access to some particular component of it, and only then you are able to either read, write, or do something else with it. You can restrict access with identity access management as well. So why restrict that with abstraction? IAM may be too complex for simple code level access restriction. See, whatever you are going to write in a system as a developer or engineer, okay, you will eventually expose it to others. It may be via as a separate service, via a module to some other service, but eventually users are going to access it. So the question still remains, users are going to access it, and every user is gated via identity access management anyway. Take a look around in your office. You have a bunch of multiple services, and every user has his own set of credentials that he is going to use. And based on those, he will either be able to access it, not access it, partially access it, whatever. So that identity access management is already there in your infrastructure. And your C++ code is not going to exist in vacuum. Suppose I don't want a variable to be changed directly, but only via a method. Why? You want to do it via a function. It may be a computed field. Okay. So does that mean that we should be hiding only computed fields and expose other non-computed fields? Is that fine? What I mean is that object's state should not be arbitrarily modifiable. Why? The question is again, why? And so far, you are simply repeating the lines that you see written in books, blogs, articles about this abstraction thing, that this should not be done. But no one is explaining why it should not be done. For least privilege. No, for that you will use identity access management. Okay, here is the answer. Okay, the answer is, okay, let me put why. The answer is to keep things as general as possible. Okay, I want this stuff to be very generic, and by keeping it very generic, I can basically deal with a lot of things which at higher level uh, kind of behave the same way, even though their exact implementation details can vary by a wide margin. Okay, and what I mean by that, okay, there is some comment because we may corrupt object state if the sum of two other values and I modify it directly to some random value, it is now invalid. Well, we can do the same mistake in that member function as well. It doesn't do do anything. So no, this is not the point. The point is to keep it generic. And for that, I will give you a very simple example here. You see this std string. So far, we have been treating it like a string, okay? And then we do something on the string. And if we want to access individual characters, we can get individual characters out of it because it kind of behaves like a vector of character arrays. And when I said that, I also said kind of. I know I did not say exactly. And why did I say that? Because we neither know about exact representation of a string in memory, nor we care about it. Okay. For example, the string, it can be either null terminated, like in case of C, or it can be in another format that is called length encoded. And in some cases, the length may be in the beginning 2 or 4 bytes of the string, or there may be some sort of padding between size and string, or it may not necessarily be one long chain of characters. Either it may be via some other data structure like a rope data structure. That is another common data structure that is used by text editors to parse to basically modify strings in place. So there are a lot of oddities and a lot of implementation details that can happen behind the string. But if I want to take a string, I want to print a string, do I really care about whether it is null terminated or length encoded, or if there is padding, not padding, whether it is on stack, on heap, whether it is fragmented, not fragmented? I don't care. I don't care about any of that. Okay, as long as I can take a string, I can read a string, and possibly I can basically pull individual characters out of it. I am fine. Okay, I don't have to worry about all those implementation details, and that is why those details are basically hidden from me, because if those are exposed, chances are I will eventually rely on them. For example, let us say that it is a length encoded string, and that implementation is exposed. Okay, so instead of relying on that string dot length function, you can be like that, whatever, why involve a function? Let us be efficient. We can read the data from this particular member variable directly. And by doing that, sure, you eliminated a function call. Sure, it will probably be just couple of nanoseconds faster. True. But now you depend upon that implementation detail. And if that std string class modifies its implementation from length encoded to say null terminated, now suddenly your code is broken because you accidentally relied on that exposed behavior. Okay, we do not want that to happen. We want to keep it generic. And if that implementation detail is hidden, you are forced to use that dot length function. And if after that I change some implementation detail of that std string, it is not going to impact you as long as I keep that output of dot length function basically correct. You don't have to care about it, and if I change something, it is not going to break anything in your code. And that is the point of abstraction. We want to hide details which are not essential to you so that we can keep it as generic as possible. So basically, it is we are basically minimizing our commitment. Okay, so we are saying that okay, we are going to commit this and only this. Everything else can change behind the scenes, but since we are committing this one, this part will remain unchanged. And since the rest of the implementation detail is not exposed, even if you want, you can't accidentally rely on that. And since you can't accidentally rely on that, if I change the implementation for whatever reason, it is not going to break anything in your code. And that is the point of abstraction. Any questions? Okay, I will take it as no question. and we will move to the next concept. Okay, polymorphism, abstraction, and polymorphism basically go hand in hand. Before that, we should cover about inheritance. Okay, the inheritance is basically we inherit some properties of some other class. And again, the question is why? So that we can extend the generic thing and convert it to slightly less generic thing, or we can redefine some of the generic things to handle some other special cases. Both cases are there. So this is basically is a relationship. So what does this mean? Here, if you come back here, here we have these member basically data members. Okay, so this is basically is has a relationship. Okay, and what I mean by that, it is basically that threat intel feed has this std string. Okay, so basically this is a smaller block, this is the bigger block. This is another part that is basically is a relationship where we are saying that this less generic thing is actually where this less generic thing is actually the more generic thing, or if in terms of math, if you want to think about it, if you have studied maths in your college, especially in engineering, you probably heard about this transformation. Okay, so there is Fourier transformation, there is Laplace transformation. So Laplace is more general case of Fourier. Okay, so basically you can say that Fourier is Laplace transformation, but except that we don't really have any complex plane here. So that is basically is a relationship. Okay, so this is that inheritance, and this basically gives us another way of merging the blocks. So here we are combining the blocks by clubbing them together and giving it a name. And here we are basically extending a box. We take a box and we expand it a little bit so that it can handle some more stuff for us, and then we can treat it as another special box, and then we use that to compose some other stuff. We can combine this abstraction and inheritance, and that leads us to polymorphism. And this is basically the act of handling different cases in slightly different manner. Okay, so basically this comes from these two. Here we are keeping it very generic, and then in inheritance we are expanding that, and we are also redefining some of the generic things, especially the functions. Okay, so the polymorphism basically says that if that happens and you focus only on that generic thing, you can also effectively deal with that special thing as well, because even though the function name is same, the object type is basically the same, the implementation will be different internally, and those cases will be handled correctly. So this is effectively an extension of the previous two concepts, and these three basically, or rather these four concepts come together, and they basically become a building block of this object-oriented programming. Okay, so for example, we can have here, or okay, so this is the class one, and there will be some other things here. So we go back to the syntax part. Back to class, we have something called access control. It can be public, private, or protected. God damn it, I can't really. Okay, yeah. It can be either public, it can be protected, it can be private. Okay, so public, it is accessible outside the class, and protected is not accessible outside the class. Okay, and private is also not accessible outside the class. It is can be in uh, can be inherited, as in if some other class is inheriting from this one, it will get access to this one as well. Protected can be inherited. Private can not be inherited, which means that order of restriction. So private is most restrictive, protected is somewhere in between, and public is basically least restrictive. Okay. Now we want to do something like this in our code here. So what I will do, I will wait, I will move it to other function. Parse JSON file. I will remove this here, and then I will define another main function. Okay, and now I want to basically define a class and do something with it. Okay, so let us define a class. Let us say we are going to define some person. So a person can have some attributes. Obviously, he will have some name. Okay, and let us say he will also have some date of birth, or rather some unique ID, ID number, or rather unique ID. Okay, and we are going to put only these many attributes here. Uh, we can keep it protected because we want this to be inheritable, and we create public function, and we basically want to return. Oh wait, no, it is std string. Okay, and similarly we want to have this unique ID as well. Unique ID, and then unique ID. Okay, we can have this, and now we have a problem. The problem is, it is basically this. I can define an object, or I can declare an object of this class here. The variables are hidden, well, because these are implementation details. I want to expose some functions here. But how do I set these values? These are not accessible from outside. Okay. So for that I will have to define one more function, set data, possibly std string, name std string, unique ID, and then what, and then I can put name equal to name, or wait, let me put it in this way, and unique ID equal to unique ID. I can put it like this. I can do something like this, and then I can obviously print it something like this: p dot get name, p dot get unique ID, and oh wait, what? Okay, I can do something like this. Build finished. It prints here, so far so good. I am able to set this, but this is kind of clunky, but we will come back to it little bit later. Let us basically expand this, okay? And let us see. I want to track details of some enrolled members, okay, or other students for some course. Obviously, each student is also a person. So what I can do, since a student is a person, student does not have a person, so I can extend this, okay. And what I will do for that, for extension, I can do this, okay, and then I can specify this, okay. So what it will do, it will inherit from person, okay, and this will keep this public as public, protected as protected. If I say protected here, then it will make this public protected, and private and protected will remain as it is. If I put private here, basically everything becomes private. So that is what that keyword does here. So this is here, and again I put some stuff in protected, some stuff in public, and we already have name and unique ID. All I need to add is std string enrollment number, okay, or I want to track std string courses. Okay, so basically this class will now have these two because inheritance, these two because this extension, okay. Okay, so and now I want to okay, I will get these as well. Just fine, I don't have to change anything here. I will have to basically define a new function for this enrollment number. So get enrollment number, return enrollment number. Okay, so this is fine. And I also need to do something with this set data. So what I can do, I can basically extend this thing here. So void set data std string enrollment numbers. Okay, and name equal to underscore name, unique ID equal to unique ID, enrollment number is equal to enroll. Okay, so get enrollment number, and then I can add some more functions. String enroll, std string course. Wait, and here I can just courses dot pushback course. Okay, so this gets in this vector. Fine. And it says, okay, one more function to get that data out. Get courses, and this will basically return courses. Okay, so I can have something like this. Okay, and instead of dealing with this base class, I can, okay, so this is basically called base class. Okay, this is a base class, and this is derived class. Similarly, this student class can be a base class for some other class. That is absolutely fine. So this is basically relative. It doesn't mean that base class will not inherit from some other class. That is not true. For this particular case, this is the base class, and similarly, if we extend this further in some other class, for that class, this will be base class, even though this class itself is a derived class for some from some other base class. So that is relative. So what I want to do here, I want to, instead of this, I want to do something like this. Okay, and set data, and what else ID do I need? I need enrollment number. Okay, so p dot, so we can build this. Build is finished, and I want to run this. Okay, so far it is going good. Now we have a problem. We said that point of this was generalization, this was extension, and this was basically we can deal with different things differently. So let us try it out. Okay, so let us have a function called print data. Okay, and what I want to do here, I want to take an object of this person class, and I want to, obviously this does not go there. And we can print data P. Okay, we can build it. We can run it. So far, so good. But let us do something different. Here in get name and get unique ID, I want to track exactly which function is getting called. Okay. Oh, okay, wait. I have not even modified this here. So let me modify this one as well. Now let us do this one. So, okay. Std string new name equal to std string. Okay, and then name, and then I want to return new name. Okay, what? Okay, fine. I want to build this again. Okay, now tell me what should happen. Here I have student class, and I am doing this p.getName. But here in print data, I am taking an object of this base class, and I am doing p.getName. Okay, so if we go back to the notes, this is basically polymorphism. Same function. In derived class, we are doing slightly different thing with the same function name. So far, it aligns with the concepts that are put here. But what happens if I run this? There is something wrong here. If we do p.getName, it is student. So this part gets executed because in name, I get this string in the beginning as expected. But if I take the object of person and I do the p.getName, I wanted this. But instead of this, it is doing this. So even though we supposedly have this polymorphism, we are not really seeing it here. Okay, and that is because this is something that we have to enable, and for that we have to use keyword virtual. So if I do this thing virtual here and I compile again, and then I run it again. Now here, even though I am taking an object of person and I call this get name, it magically arrives here, which is defined in this student class. Okay, so that means if I specifically say that, okay, this function is something that can be twisted and turned into a polymorphism type case. What happens that if I want to understand, I want to deal with basically all types of person objects, instead of trying to figure out how many times it has been derived from, what are the derived classes, their names, I don't have to care about any of that. I only care about the base class itself. And by doing something like this, these function calls magically resolve to the function calls which were defined in corresponding derived classes. Okay, that means that this particular function has become very generic one. Within that function, I don't care about what you do with that person class. You can derive it once, derive from it 10 times, or it may go like 20 layers deep. I don't really care about any of that. All I care about that person class, couple of function it defines, and the rest of the stuff is basically left for you. Okay, and if I am doing this, does not matter how many times you have derived it from, or how deep goes how deep that inheritance layer goes. This thing will be able to handle all those special, super ultra pro max level special cases just fine because of that inheritance and polymorphism and basically this magical keyword here. Okay, so basically this is the polymorphism part. Same type, same object, but depending upon the derived type, this thing will magically lead to some different implementations of this thing. So okay, wait, what? So p dot get name, same base class, same function name, or different invocations for different derived type without us having to do something special. And this is polymorphism basically. Okay, any questions so far? Can you share the Discord link? Wait. Animesh, can you please share the Discord link in the chat?
Okay.
Please explain again what is meant by class student public person. Okay, okay. This one. Okay, so this is we are declaring a class. This is the name of the class that we are declaring. This colon says that we are going to derive from some other class. This is the name of the class that we are deriving from. And this is basically telling this is basically setting that access control for the derived class. So it basically goes like this. Okay, inheritance syntax. It is like class derived class name access control. This is base class name. So inheritance access control, and this is base access control derived class access control. So this is basically this. Okay, you define it as public. So base class public, it remains public. Okay. Base protected, it remains protected. Base private, it remains private. You define it protected. Base is public. Okay, wait, what I can do? I can just copy it here and you define it protected. It is protected. And private remains private. So this, if you define, if you put that protected keyword here in this place, This will turn public stuff from base to protected stuff within derived class. Similarly, if you mark it private, public becomes private, protected becomes private, and well, private becomes private. So if you look at it, you can only restrict the access further. You can't really relax it. Okay, so if base class has marked something as protected, you won't be able to mark it as public, not unless you add some extra members and expose it that way. Okay, similarly, if base class has marked something private, you won't be able to see it at all. Okay, but if base class has marked something public, you want to keep it protected within your class, you can do that. You want to turn it into private for your class, you can do that. So you can basically, when you are deriving from that base class, you can either keep the access control same, for that you specify public, that doesn't really change anything from the base class, or you can restrict stuff coming from base class further within your derived class. That is what that keyword in this place uh, does here. Any other questions? Okay, I suppose no one has any questions, so we will wrap this up uh, uh, here, and in next session we will talk about some more stuff related to these classes and objects. Mostly we will be talking about function overloading, overriding. We will be talking about things like operator overloading, constructors, destructors, bunch of different destructors and constructors, their ordering, how they execute, not execute, that sort of stuff. And after that, we will move on to some other stuff. Either it will be related to threads or it will be related to some network related stuff.